Hello, welcome to Ludic Science. In this video I will show you this device which is known as the linear variable differential transformer, and as we will see, it is used to measure distance. The way in which it works is rather simple. We have here a transformer. The center coil is the primary and the two coils at the ends are the secondaries. The secondaries are identical and they are connected in series, but the connections are in such a way that the voltages have opposite polarities and therefore they cancel out each other and the reading is zero. That is in normal circumstances when everything is symmetrical, when the core is at the center of the coils. However, if one of the coils produces more voltage than the other, we will observe an output voltage that is indicative of how much the core is out of center. Therefore, moving the core to one side or the other produces a voltage difference at the output. And we can use that to measure the distance that the core moves. Next time you need a PCB for your electronics project, consider using the professional services of JLC PCB. JLC PCB is the world leader in PCB fabrication. You can order online. You just need to register, upload your Gerber file, and wait a few days for your PCBs at an unbeatable price. This is the transformer. It has 3 coils. Each one is made with 250 turns of magnet wire size 28, and they are coiled in the same direction. The center coil will be our primary and we have 2 secondaries at the end, and I will connect the 2 secondaries in series, but in such a way that the outputs cancel each other out. That is, in the left secondary we have the initial and final winding, and in the right secondary we have the beginning and the end. So I will connect the end of the first secondary to the end of the right secondary. And if the transformer is symmetrical, the outputs will cancel and we will have 0 volts of reading. But if things are not symmetrical, one secondary will produce a higher output than the other and we will obtain a reading. Here I made the connections of the 2 secondaries. This is the output, and here we have the connection of the primary. And this is the core of the transformer. It is an iron core, and we will introduce it here in the tube. And if the core is symmetrical with the coils, we will obtain an output reading of 0 volts, because both secondaries will produce the same voltage but with opposite polarities. However, if the core moves to one side or the other, then one of the secondaries will have a higher voltage than the other, and we will observe the difference in the output. And this voltage at the output is proportional to the distance that the core moves from the center. So we can use this voltage as an indication of the distance that the core moves to one side or the other. So let's now do the test to observe this effect? Well, here it is. I have connected the multimeter in AC reading to the output of the two secondaries that are in series, and I will apply AC to the primary, that is the output of this transformer, 6 volts AC. So let me connect the primary, and you can see that we have a reading of 0 volts because the core is at the center of the coils. But if I move it to the left, then you can see how a voltage develops and is increasing as we move the core out of the center. And okay, here is at the center again, 0 volts. If I move it to the other side, to the right, we also observe the voltage going up. Okay, as you could see, we can use this device, and in fact it is used in industry, to test the distance that an object moves. You center the core so that you have 0 volts, which is a 0 distance reading, and when the core moves, you will start to observe a reading that indicates the distance that the core is moving, either to one side or the other. Okay, so there you have it, a simple device to measure distance with precision. I hope you liked this video. If that is the case, please visit my Patreon page. Thanks for coming to my channel, and see you in the next video.